We've all watched skylines reach for the clouds, but which towers truly rule the air? These are the champions of signal and steel, turning wind, lightning, and quakes into trophies. From a riverfront wrapped in mist to a megacity of neon, we're counting them down, starting at number 5 and rising to the ultimate crown. These are the 5 tallest TV towers in the world. Before we ascend, a quick note on terms you'll hear. A tower is not a typical office building. Buildings are meant to be lived and worked in across many floors with large areas of continuous occupancy. Towers are slender, often with just a few pods or decks for people, and their main mission is broadcasting signals across the urban maze. That purpose changes everything, from the geometry to the materials to how the structure handles wind and, in some places, earthquakes. With that in mind, let's climb. Number 5. The Oriental Pearl Television Tower in Shanghai, China. Built from 1991 to 1994 and opened in 1995, the Oriental Pearl doesn't just pierce the skyline, it stages it. The design reads like a string of planets in orbit, multiple spheres stacked above a robust base, with a needle-slender spire finishing the composition. At roughly 468 meters tall, it became the playful signature of Lujiazui long before the district filled with supertalls. The magic here is hybrid thinking, steel and concrete, curves and columns, spectacle and service. Inside those spheres, the structure carries observation decks, exhibition spaces, and restaurants. Each pod, effectively a building within a tower. The geometry spreads loads along the vertical axis and braces the shaft against crosswinds common along the Huangpu River. When night falls, lighting washes the spheres like stage cues, syncing the city's financial tempo with a cultural heartbeat. It's tourism, telecom, and a postcard, all in one. Why it mattered. In the 1990s, Shanghai needed a modern broadcast hub and a new global identity. The Oriental Pearl delivered both, proving that communications infrastructure could be a public icon, not just an antenna on a roof. Number 4, the Ostankino Tower in Moscow, Russia. Decades earlier, Moscow asked a radical question: how high can pre-stressed concrete go? The answer, completed in 1967, was Ostankino, rising to about 540 meters. It became the world's tallest freestanding structure at the time, a broadcasting exclamation mark above the capital. Pre-stressing concrete is essentially loading the material before the real loads arrive. High-strength tendons are tensioned inside the tower's core, compressing the concrete and letting the slender shaft resist tension and bending far better than ordinary concrete would. Pair that with a broad, weight-spreading foundation, and you get an ultra-tall mast that stands stoic through brutal winters and heavy winds. Ostankino's story also carries a hard-won lesson. A serious fire in 2000 prompted a wave of safety upgrades, smarter compartmentation, improved cabling, and emergency systems, so that the tower could continue serving millions who rely on over-the-air broadcasting. The engineering triumph is not just height, it's resilience, learning from crisis to build a safer future. Why it mattered. Ostankino proved a concrete tower could reach unheard of heights, setting a benchmark that echoed across continents for the next generation of record setters. Number 3, the CN Tower in Toronto, Canada. By 1976, Toronto faced a problem. Downtown's boom was creating a forest of steel and glass that blocked broadcast signals. The solution wasn't to add antennas to rooftops, it was to go far above them. The CN Tower lifted the city's communications into clear air, topping out near 553 meters. Construction read like a masterclass in vertical speed and precision. Crews used slip-form concrete, a continuously climbing mold, to pour the tapered shaft day after day, while a triangular base with 3 supporting legs spread the foundation loads. Up top, a multi-level pod carries observation decks and a revolving restaurant. Later, an adrenaline-pumping outer ledge walk wrapped the tower in pure theater. Technically, the CN Tower was also a wind lesson. At that altitude, gusts can twist and sway a structure in complex rhythms. Engineers tuned the mass and stiffness of the tower, and the aerodynamic profile helps shed vortices that might otherwise set the shaft singing in the wind. The result is a structure that feels carved by the air itself, lean where it can be, heavy where it must be. Why it mattered. For more than 3 decades, the CN Tower set the global height bar for freestanding structures. More importantly, it reframed the skyscraper city not as the problem, but as the reason to go higher. Here's a quick pit stop on how engineers tame the forces that try to pull these giants down. Wind never hits as a steady push. It arrives in pulses, shedding little whirlpools of air that tug side to side. To fight that, designers sculpt the tower's shape to confuse the wind, then fine-tune stiffness so the natural sway sits outside the most dangerous rhythms. In earthquake zones, the problem flips. You want the structure to absorb and release energy without snapping. That's where dampers, sliding connections, and central columns come in, letting parts of the tower move slightly out of sync to cancel the worst shakes. In short, height isn't the only challenge. Timing is. If you're enjoying the video, kindly like and subscribe. Number 2. The Canton Tower in Guangzhou, China. When it opened in 2010, it didn't just add height, it rewrote the silhouette of what a tower could be. Rising to about 600 meters, its steel hyperboloid lattice twists like a dancer's waist, cinching at the middle before widening again near the top. The result is a shape that looks impossibly slender, yet stands brutally strong. That elegance hides a brilliant structural strategy. The steel exoskeleton forms a diagrid, a crisscross network that shares loads efficiently, reduces the amount of material needed, and resists wind from multiple directions without bulky braces inside. A concrete core threads the center, adding stiffness and housing elevators and services. Outside, the rim hosts a bubble tram that circles the crown on clear days, turning the skyline into a moving panorama. Guangzhou sees powerful winds and seasonal storms. The tower's curvature helps shed vortices and cut wind pressure, while the diagrid disperses forces into thousands of triangulated members. Its architecture and aerodynamics in a precise duet. Why it mattered? Canton Tower proved that the world's tallest towers could be light and lyrical, not just thick and imposing. An exoskeleton-first approach that engineers and architects still study today. Number 1. Tokyo Skytree in Tokyo, Japan. Completed in 2012, it stands around 634 meters, built for one of the most demanding broadcast and seismic contexts on Earth. Tokyo needed higher, clearer signals after the city's skyscrapers grew taller, and it needed a structure that could outsmart earthquakes without flinching. Skytree does it with a uniquely Japanese solution, a modern take on the ancient Shimbashira concept. Think of a central column that can move slightly out of phase with the outer structure. During a quake, that inner column absorbs and dissipates energy, acting as a built-in damper. Around it, a steel frame and reinforced concrete core form a tapering tripod-to-circular profile that optimizes both stiffness and aerodynamics. At its lower levels, the tower reads as a 3-legged giant braced to the city. As it climbs, those legs blend into a rounded shaft, reducing wind load and creating a cleaner, lighter profile for the sky. The observation decks, first high then higher, turn the metropolis below into a living circuit board, trains pulsing, rivers threading, districts glowing like constellations. Why it mattered? Tokyo Skytree is the definitive statement that a tower can meet 21st century demands. Ultra-precise broadcasting, typhoon-level winds, and seismic shocks, without sacrificing grace. It's a cultural landmark that also happens to be an engineering thesis. So what is it actually like to visit these giants? You start on the ground as a dot in a crowd, then race upward in an elevator that feels more like a capsule than a cab. Doors open to a horizon you didn't know your city owned, streets flatten into threads, rivers become ribbons of light, and the sound of traffic turns into a soft, distant hush. At dusk, you watch the city switch on like a circuit board, towers blinking, bridges glowing, neighborhoods clustering into constellations. Whether it's a glass floor under your feet or a rim right around the crown, the experience is part science lesson, part theater, and part meditation on scale. Keeping these structures healthy is a story of constant care. Crews inspect steel nodes and concrete skins. Lightning protection gets tested and retested. Paint and sealants guard against rain, salt, and sun. Cables, lifts, and electronics get refreshed as broadcasting technology marches forward. A tower is never finished. It's maintained, tuned, and upgraded the way a concert piano is tuned before every performance. Across 5 cities and 5 eras, the recipe keeps evolving. Purpose first. Every tower starts with signal. delivering radio and television and increasingly data across complex urban canyons. Form follows forces, from Shanghai's spheres to Guangzhou's twist, Moscow's compressed concrete to Tokyo's damped core. Shapes are not arbitrary. They're answers to wind, weight, and quakes. And there's a public payoff. Observation decks, restaurants, and thrill rides turn infrastructure into civic theater, bringing citizens up to the horizon that technology created. And where do we go from here? As cities get denser and data demands grow, future towers may fold in smarter antennas, sensors that learn from every gust and tremor, and materials that actively damp movement instead of just resisting it. We may see new hybrids that blur the line between tower and building, weaving public spaces, green terraces, and communications hardware into a single vertical ecosystem. Whatever form they take, one thing is certain. The frontier isn't just up, it's smarter. There's a pattern in the timelines. As cities densify, rooftop antennas grow insufficient, and towers become the clean air lane for communications, pushing us higher, then higher again. Which tower impressed you most? The lyrical twist of Canton, the fearless resilience of Ostankino, the sky-quieting efficiency of the CN Tower, the luminous theater of the Oriental Pearl, or the earthquake-smart genius of Tokyo Skytree? Tell us in the comments and let us know which giant you want us to cover next. Then like and subscribe to help us keep building stories that climb.